Hello students, Miss Slyman here. I'm not going to do the warm-up for 5.3. I'll leave you to do that warm-up on your own. You should be able to figure this one out. Arithmetic series, sum of 200, how many terms, so we're looking for the n value. So now we're going to talk about infinite geometric series, and you can see that I started this video once and stopped it, which is why there's already writing here, because these L's here are typos. It comes from Mac versus PC. So these L's here should be ... So I'm going to go in and instead of L, ... plus ... down here, ... So instead of L, ... Sorry about that. All right, so looking at infinite geometric series. Well, first of all, we start with this condition that the absolute value of r is less than 1. So if we think about what that means, it means r is some sort of fraction less than 1. Not necessarily fraction, could be a decimal as well. So we could have 1/3 or 1/6 or. Many examples. But if we've got a fraction, if we think about what happens, well, I start with this first term, and then I multiply by a fraction, so it gets smaller. I multiply by that fraction again, it gets even smaller. Multiply by a fraction again, it gets even smaller. It gets so small to a point that eventually at the end, it's like we're adding 0. So as our n value gets really big, a fraction raised to a really big number, so let's look at an example. Let's take 1/3 and raise it to the 10th. So 1.69 times 10 to the negative 5, so 0.00001. If I go even further, let's say we raise it to the 100th power. 48. So 1.9 times 10 to the negative 48. So 0.00047 times 19. So I'm essentially adding 0. So my infinite sum will have a value. And this value is going to be this formula. So let's think about why it's that formula. So if we take the limit as n goes to infinity, so limits coming back, of our sum formula. So we have a1 times r to the n minus 1 over r minus 1. Well, as n goes to infinity, r to the n turns into 0. So this would turn into a1 times 0 minus 1 over r minus 1. Well, 0 minus 1 is negative 1, negative a1 over r minus 1. If I move that negative to the bottom, positive a1 over 1 minus r. So this only happens if r is less than 1. Absolute value of r less than 1 means that this limit turns into 0. Okay, so here's our formula for the sum of an infinite sequence. Now let's practice with it. Find this sum. Okay, so I've got u1 is equal to 2. If we look at what we're multiplying by each time, our r value, 4/3 divided by 2, that's going to give me 4/6. It's 2/3. So r is less than 1. That's true. So our sum to infinity then is going to be equal to u1 divided by 1 minus r, 2 divided by 1/3. So the limit is 6. Let's look in our calculator and see if our calculator supports this. So if I put in my sum formula, make this a bit smaller, I'm going to go into y equals, I'm going to turn off my plots. So I'm going to put in my s sub n, my usual formula. So I'll make a fraction, and I'll have u1 times my r value. That is, let me put it in parentheses here, 2/3 raised to the x minus 1 over 2/3 minus 1. All right, so now if I look in my table, I'm going to go into my table, start at 0. I'm going to count by tens. All right, so notice even as soon as 30, my calculator's calling it 6. If I move over into these decimals, I can see a bit more accurate. So 5.999, and that's just at 30 terms. So definitely my limit is going to 6. I could also look at this by looking at the graph. So I'm just going to go, I don't know what my current zoom is. I'm going to look at a zoom standard. And at some point I'll get my sum. So my sum, my first term is 2, and then my sum approaches this horizontal asymptote at y equals 6. So there's sum of an infinite sequence. I'll be back in the next video with example 2.